Hi, today we are going to go over the basics of waves. What is a wave? It's a periodic disturbance in a solid, liquid, or gas as energy is transmitted through a medium or space. And it carries energy through matter or space. We have different types. First off, we have mechanical waves. These are the waves that need a medium. And if you don't know what a medium is, it's basically the physical environment in which the wave travels. For example, a sound wave, the medium is air. Electromagnetic waves, on the other hand, do not require a medium. That's because they are alternating electric and magnetic fields. This allows them to travel through space. They consist of changing they consist of changing electric and magnetic fields in space. We have several types: visible light, which only actually makes up a small portion of the light waves, radio waves, which we cannot detect with our eyes, and then also some other ones would be like X-rays and gamma rays. Here is a little animation showing the alternating electric and magnetic fields. So you kind of have like an electric and a magnetic wave. And we will have a whole unit over this later. So here is the electromagnetic wave spectrum. They travel at 3 times 10 to the 8th meters per second. And then this little chart kind of tells you how they are differentiated. They are differentiated by the wavelength and the frequency. The bigger the wavelength is over here, but the bigger the wavelength, the lower the frequency is going to be, and then the smaller the wavelength, the higher the frequency is going to be, and the frequencies are down here. They start out at 10 to the 4th hertz, and then the higher frequency are going to be over 10 to the 20 hertz. Waves can also transfer energy and therefore can do work. The bigger the wave, the more energy it can carry. For example, tsunamis can do a lot of work because they are carrying a lot of energy. So can high energy electromagnetic waves. Those high energy electromagnetic waves can actually cause, damage to living things. Energy as a wave travel. As a wave travels, it may seem like the energy is dissipating, but it's not really dissipating. What happens is that energy is spread out over a larger area. So as the circles spread out or get larger, the amplitude gets smaller. And then an example of this is why standing close to a speaker is going to be so much louder than somebody who is further away. This follows the inverse square law, just like our law of universal gravity. So if you are sitting, let's say, 2 feet from a speaker and your friend is sitting 4 feet from the speaker, you are going to hear the sound 4 times louder than your friend. Oh, and then here's another example. 2 times further away from a speaker than your friend, how does that affect the sound you hear? And then in this case, you would experience 1/4 of the loudness. We also have we also can categorize waves by how they travel or the shape that they take when they travel. The first type is a transverse wave, and they have perpendicular motion. The particle motion will be perpendicular to the direction the wave is moving. So in this picture here, you can see that the wave is traveling from left to right, but the particles are moving up and down, or the slinky is moving up and down. Examples of transverse waves would be like light waves and ocean waves. Longitudinal waves are the opposite. They compress and stretch the wave. The particle movement here is going to be parallel to the wave motion. And And then areas where they're compressed is going to be called compression. So if you look at this slinky where it's compressed, it is referred to as compression. And then regions that are stretched out are called rarefaction. So you can see where those are on that picture right there. Examples of longitudinal waves are sound waves and P waves, which are earthquake waves. And then here's some animations for transverse and longitudinal waves. Okay. Here we have a transverse wave, and you can see that the particles are simply just moving up and down, whereas the wave is moving from left to right. And then here is our transverse wave example. The waves are moving, from left to right, and if you kind of hone in on this one red particle, you could see that that particle is simply just moving back and forth. Okay, and so it's moving parallel to the wave propagation. And that's all we have for today.